Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, Assalamualaikum warahmatullahi wabarakatuh. So in this video, I would like to give a brief introduction about topic number 3. Okay, topic number 3 is actually part of displacement method of analysis. Okay, and the name of this topic is moment distribution method. Okay, so right now I am referring to the textbook, chapter number 12. Chapter number 12 is all about moment distribution method. And actually in chapter number 11, okay, chapter number 11 is also displacement method of analysis. Okay, but okay, the specific method is called as a slope deflection equation or slope deflection method. Actually, these two methods, okay, slope deflection method as well as moment distribution method, both of these have same outcome. So both of these, okay, whether it is slope deflection method or moment distribution method, okay, slope deflection method or moment distribution method, okay, both of this method, okay, actually have the same outcome, where we need to calculate what we call as member and moment. Member and moment. Member and moment. Okay, member and moment. So in understanding moment distribution method, there are many terms that students need to understand, but the most important things is okay, the learning outcome. So what is the learning outcome for moment distribution method? So we look at this. Okay, so moment distribution method. Okay, we will solve indeterminate beam and frame. Okay, we will solve the member and moment. We will analyze beam and frame to solve the member and moment. Solving, okay, member and moment. So what is actually member and moment? So member A, member B. What is member and moment? So member and moment, this is MBA, this is MAB. So MAB and MBA is actually called as member and moment. So if we have, for example, member ABC, okay, for beam with 3 element or beam with 3 members, so we will have member AB and then member ABC. Okay, so for member BC we have member and moment. So this is MBC, this is MCB. So MAB, MBA, MBC, MCB, and if we have another element or another member, member CD, member C and member D, join C and join D. So we have member, we have NC and ND. So we will have MCD, MDC. So we will analyze beam and frame to analyze what we call as member and moment. The main objective of analyzing structures, beam and frame using moment distribution method is to analyze member and moment. So what is member and moment? So each member has two end. Each member has two end. Okay. One element consists of two join, two nodes. Okay, one element consists of two nodes. So we have node A, node B. Join A, join B. Okay, A and B. Okay, A and B is called as N. Okay, member N. Join is member N. Okay, and moment at join is called as member and moment. So each element will have, okay, each element will have two. Okay, so MAB and BA. For member AB, we have MAB, MBA. Member BC, we have MBC, MCB. Member CD, we have MCD, MDC. And the direction that I put here, okay, the moment direction I put here is actually based on the sign convention. Okay, this is actually the assumption at the beginning of the process. Okay, I put this direction because the sign convention we use in this topic is clockwise. Okay, clockwise positive, clockwise positive. Is clockwise, not clockwise positive, is clockwise. Okay, the sign convention that we use is clockwise. Okay, clockwise. So if we have moment which is negative, mean it is counterclockwise. Okay, so that's number one. Number one, okay, I mentioned about the output, okay, or the learning outcome. Okay, we need to analyze member and moment. Member and moment. What is member and moment? Member and moment is moment at join. Member, moment at nodes. Okay, we call join as member n. Okay, member n, and there is a moment, internal moment at each join. Okay, so this is the basic okay, the story about actually the moment distribution method. So I just want to focus or to highlight the term, the output and the important terms that student need to know. Okay, this is about what I have told just now. Sign convention, clockwise moment that act on the member are considered positive. So it is like this, positive clockwise. Okay, positive clockwise use in Hibbeler. Okay, okay, positive clockwise use in Hibbeler textbook. Use in Hibbeler textbook. Okay, the other terms that okay that you need to know is fixed end moment. Fixed end moment. So this fixed end moment, actually you have used it, okay, in stiffness matrix method. Fixed end moment. Okay, fixed end moment. Okay, we need to refer to the same formula that we have actually referred previously. Okay, fixed end moment, because and remember, fixed end moment is actually the value that we get from fixed end moment. Okay, the direction that we get from fixed end moment is actually the behavior, not sign convention. Okay, we put the sign in the moment that we calculate. Okay, for fixed end moment, the sign that we get is actually referring to sign convention that we assume. Okay, fixed end moment. And then the other terms that we need to understand is called as member stiffness factor. It is K, and K will be depend on, okay, condition, far end condition, far end condition. So we refer to far end fix, and another one is far end pin or roller. Where for far end pin or roller, we will use 3 EI over L. So these are the two stiffness factor that we need to remember. Okay, we will use this in analyzing beam and frame, the famous one. Okay, and then the next term that we need to understand is joint stiffness factor. Okay, we have stiff member stiffness, and then we combine to have joint stiffness factor, joint A. Okay, and then after that we will calculate distribution factor. So this is actually the procedure. The distribution factor, we have to calculate distribution factor from formula. Okay, we get from member stiffness factor divide by joint stiffness factor. So this distribution factor is very important, and we will use this whenever we distribute moment. We distribute joint moment using distribution factor in the table. Okay, in the table. So this is just to show the concept. Okay, how actually we distribute joint moment. Okay, from joint moment we distribute moment using the distribution factor, and we will distribute it to the adjacent. Okay. Okay, and another important term is called as carryover factor. It is COF 0.5 and 0. Okay, depending on far end condition as well. Depending on far end condition as well. This is for fixed end. This is for roller end. Roller and or pin. Okay, or pin. Okay, and to understand, okay, about the process, I suggest you to follow straight away. Okay, wait. Okay, this is the procedure. So please read the procedure, and then okay, straight away refer to this example 12.1. Okay, 12.1. Okay, just follow the procedure as shown previously. Okay, and this is the procedure that you need to follow. Start with derivation of K. This is the first step, and then calculate distribution factor number 2, and then from that we calculate fixed end moment, and all this we put into the table, and we do distribution process, and the total moment that we get from the table is actually the member end moment, the answer. Okay, the internal moment, and all this moment we transfer into diagram. So into diagram, and we draw the bending moment diagram. Okay, for the process inside the table, okay, please use the video that I have put the link in the Teams channel. Okay, so this is about introduction about beam analysis using moment distribution method. I hope you will take some time to watch my previous video regarding this topic, and hope you will understand. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.